Okay, let's go.
Okay.
No, I want to see the post conditions. Cool. Where's the post condition?
Yeah.
Uh, okay, okay.
Okay, can.
Mm. So I'm doing your test case review now. Okay.
I
Next
think
person. That's all.
that's
Uh,
all for my part. Yeah.
Okay.
Miss, is it
Yes.
really needed for us to fill in this part? Because for my form, sometimes it doesn't really show anything
No,
unless it's the
expected
envelope.
system response. It's only when the system is giving any response for that particular action. If that action don't have any response, you don't need to fill up. When you don't have expected system response, then you don't have pass or fail. Maybe the entire 10 steps you have, 10 action you have, maybe your expected system response is only one at the end. So you will only have one expected system response and one pass or fail. Done. But
Okay,
sometimes some system, every single thing you are doing, it is doing some response. Then you will have for each of them. If you don't have, then it's okay. Got it?
okay,
Because it's depend with how your functionality. Sometimes some form it is doing automatic validation every time you filling up something, every time you select something. But sometimes nothing happen until you click the last button maybe. Then it means you have only one expected system response and you have one status. That's it.
okay.
Mm.
Okay. Miss, for this assignment is submitted this Sunday or
Yeah, correct.
okay, this Sunday. Okay, can.
Can submit right Sunday.
Guys, you guys okay or not?
Everyone can submit on Sunday, right? Okay, can. Good. By 12 a.m. I will
Mm.
create the assignment submission for you to upload it.
Miss, is it tomorrow morning we still can consult you about this assignment?
Yeah, can. No problem.
Can so okay, can.
Mm. Not misses, meets. Okay. Any other team members from this team to check the test case? Sorry, can you go on the top part, the header part of the test case? This
Header
one,
part.
this one. Yeah.
So,
Uh, you guys follow like how we discussed, right? The test case ID. Um,
Yeah.
wait,
The design there and execution there is like once before, one after.
Mm. Service module, parcel shipment. What is your module? Because on the module, why you put parcel shipment? Module
Oh,
suppose should
that
be
one is
service module.
the
No, no.
service module only. I need to take off.
Uh, uh,
Mm.
Bernard, can I see your test case? Is it
sure. This is my first one.
okay? We are not having the same format here. Please don't include the positive test case on the header like that. Don't modify the template which I gave you. Please don't change anything. Okay, can I recall back how we suppose should do the test case ID? I thought I said like a system name, underscore, module name, underscore. Is it? Is it system name? testing, we actually can drop the certain features where it has been affected until the development team can actually fix the defect, and then they can integrate back or they can join it back. Okay, so normally, uh, how to say, the development team, I think we have discussed this on our chapter 6, huh? Development team can actually request for waiver. I think we have used this under our failure type of failure. So the development team can actually request for a waiver for them to take over, or they remove over the particular functions or the particular module from the system temporarily until they can fix it. So if they have removed out or they have inactive certain things, okay, after request for the waiver, it means we as the testing team, we can continue with our testing without that part. So this can be actually part of the action which we can do for us to move over for the testing to be continued. So it means we will temporarily drop the features or drop the module which contain the defect which cannot be solved. Can understand? So that can be part of the action to be taken. So first action is how we, if we can continue, okay, with the features by using any uh, dummy code for temporary purpose. Yes, that is one action. Another action is if it cannot be replaced with any dummy code, or we development team cannot do that, so it means we need to drop the features. Okay, we need to drop the features or the functionality temporarily for us to continue with the testing while we are waiting for the development team for the fixing. Okay, so let's assume if the development team cannot fix it at all, okay, it means we will totally remove out the module or the functionality from that particular test cycle. So it means we will not include it in that particular test cycle. So we will continue with the testing and complete the testing and achieve the test criteria, exit criteria, without this particular function or module which contain the defect. So it means it will happen on the next cycle. Okay, so this can be some of the solution or some of the action can be taken when a defect cannot be solved. Okay, got it? Can understand? Okay, so we're done with the question 5. Okay, question 6. What is a test incident report? What is test incident report? What is test incident report? Huh? What is test incident report? Forgot? Okay. Written description of an incident. What incident? What incident? And when? this incident happened? Please give me complete answer. When we said incident, what does that mean? Copy back from the slide, is it? Okay. So when we said incident, it means any unexpected behavior. Of course, incident is also referring to defect, but not only defect. So incident referring to defect or any unexpected behavior or response of a system during the testing or during the test execution. So it means while we are doing the test execution, the system give defect or the system responding or behaving compare sorry different way than what we expect. Okay, so this is what we call as an incident. So every time when there is any incident means negative incident, when there is any negative incident happen during the test execution, we must report it. Okay, so we need to put in a written description of the incident happen during the test execution. Okay, so this test incident report will be a proof of what incident happened, what we how to say what we face during the test execution. Okay, because it is part of the reason um, when we cannot follow our test what to say cannot follow our test plan 100%. Okay, so this test incident report will be a written description of any negative incident happen during the test execution. So when we said negative incident, it can be defect, it can be unexpected response, unexpected behavior of a system. Okay, and this test incident report will be the proof of what incident happened. Okay, got it? Clear? Okay. So the next two question is about the configuration management. So the first one is define configuration management and explain why it is important. Then the following one is identify the configuration management activity. So I prefer to directly use the slide because it's too many things to say. Okay, so define the configuration management means, okay, so configuration management is a system engineering process, okay, which is used for establishing and maintaining consistency. Okay, for establishing and maintaining consistency. Product here means referring to the system or the software of a product's performance or functional and physical attribute, okay, with its requirement, design and operational information or any other item. So how it can maintain the consistency between these two sides. One side is all the item we need throughout the software development life cycle, and another side is the end product. It means the end product of the development, the software's functionalities, the software performance, how these two sites are consistent. So, this configuration management is a system engineering process which can establish and maintain the consistency between these two sites. Okay. So, the importance of the configuration management is actually helpful. Okay, it will be needed for the storing, for the tracking and updating all the system information, okay, throughout the software development life cycle, because we need to make sure that all these items which we have developed throughout the software development life cycle need to be stored accordingly, need to be tracked accordingly, and all the update need to be done accordingly. So with the help of configuration management we can do that. Okay, so that is why it is important to have the configuration management. Okay, so the next question is the activities, configuration management activities. And the question said identify configuration management activities in software testing. Okay, so this one is actually the activities of the configuration management as a general for the throughout the software development life cycle. And if we said in software testing, so all these items here will be more to items related in software testing. So for example, the first activity is it can be used for identifying and defining the test items in the system. So when we say test items, it means like the test case, the test item, the test case, test data, test result. So all the relevant items needed in the software testing. Okay, then controlling the change of this item throughout their life cycle. So it means throughout the software development life cycle or the software testing life cycle, there will be changes happen to all these testing related items. For example, changes on the test case, changes on the maybe test data, or changes on the requirement cost, the changes on the testing side. So we need to use the configuration management to do the controlling of the changes. Okay, then the same thing can use for the recording and reporting the status of the change request happen on this item. So when there is changes happen in the requirement, automatically we need to do changes in our test case. So in that case, we cannot simply do the changes without a proper recording and the reporting of the status to know if this item has been done, it has been approved, or it has been rejected. So we need to know all this status accordingly. Okay, and the last activity will be to do the verification and verification on the completeness and the correctness of the testing related items. So it means like when we do the traceability, so we want to make sure that the test items it's correct according to the test cases, test data, the test result, all this is correct, all this is complete. So we can use this configuration management to do the verifying on this completeness and the correctness. Okay, so this will be the four activities involved in the configuration management. So from this general statement, you just change it to the software testing related items. That's it. Okay, got it? So that should be our tutorial 9. So we have discussed all the 9 chapters for the software testing. Okay, so the next 3 chapters will be software quality assurance. Okay, any question? Everyone okay with all the question? Okay, so let's see what is this chapter 10. So the last 3 chapters is more to software quality assurance. Okay. So chapter 10 we will be discussing about the software quality assurance, how it's different from the software quality control, and then we will discuss about the software quality factors based on this one model, and then we will discuss about the software quality assurance system, and there is components, 6 different components. After that we will discuss on the software quality assurance activities in software testing. So it is kind of like very long chapter, chapter 10. Then chapter 11 we will be discussing about software quality metrics, where we will be seeing some metrics. It means to do with calculation. So for your final exam you need to bring calculator for you to do calculation question. Okay. Other than that, in chapter 11 also we will discuss about uh, there is total quality management, also about the quality aspect in the organization, and then the last chapter will be software quality assurance standards. Okay, so we cannot complete the chapter 10 today, but we will start with the chapter 10, the first part of the chapter 10, to discuss what is this software quality assurance. I believe you have heard software quality assurance, and you also might heard about quality control. Uh, Forget about the software first. You might heard quality assurance and you might heard quality control before we can relate it to the software side. So, what do you understand about quality assurance? What you understand about quality control? Nothing about software quality assurance. Huh? My question is general question. What you understand about quality assurance, quality control? Have you heard that? Have you heard these two? QC. People say QC, quality control. Where you have heard this QC, quality control, or QA, quality assurance, where you have heard it. Forget about software quality assurance or software quality controller. Okay, so in restaurants, have you heard both quality assurance, quality control, or you have heard quality control or quality assurance only? Which one? It means in the restaurant. Others in the others other than restaurant, where you have heard it, quality assurance or quality control. Okay, it's a job posting, so you might see like quality control engineer, quality assurance engineer. I believe that. Okay, so when we say quality control, quality assurance, okay, normally it's not only in the restaurant or this type of organization, but actually in many other organization, even like in a manufacturing site, in a production site. So all these companies, all these factories, they actually use this. Okay. uh, Maybe they make sure my burger actually has a patty in it. Okay, so what they do the QC, is it? They do the quality control checking before they deliver out to you. Okay, so if you see this production company or this manufacturing company, they give importance on this quality control. Okay, so what they do actually is, before they deliver out their product, okay, doesn't matter any product which is manufactured, before the company is going to deliver out this product, they will do the quality control checking. They call it QC, quality control. Okay, so what they do here is, QC means, quality control means, they will check on the produced or manufactured product if the quality is follow the given requirement or not. Okay, so let's assume we have these electronic parts. Okay, these electronic parts normally will have its own measurement, like okay, this is the width, this is the length, this is how should be the height, so there is certain measurement which is already done earlier. Okay, so now when this item has been produced or has been manufactured, okay, there will be a QC department where they will do the checking, okay, to confirm if this item fulfill those requirement or not. Okay, so this will be done after the item has been manufactured, before it will deliver out to the client. So when they do this QC, and if there is any item which did not fulfill the requirement, it means it did not follow the measurement given, this item will be rejected. Okay, that is the purpose of QC, quality control. They check on the final produced or manufactured product if this product is fulfilling their quality requirement or not. If yes, it will be go into the delivering part, shipment part. If it's not, it will be rejected. Can understand what QC it's doing? What quality control is doing? This is not quality assurance, quality control. Okay, can understand? I just check the final product. If the final product is fulfilling the requirement, then I will deliver out. If it's not, then I will reject it. So sometimes you can see some items, not only electronic parts, but any manufactured product. All of a sudden, you can see straight from factory, 90% discount. All of a sudden there is sales on a new produced or new manufactured item. Have you realized that? Have you realized this kind of sales happen all of a sudden? Because they have rejected the items due to fail to fulfill certain requirement, but the item can be still used, but maybe there is some little defects which they cannot proceed with the shipment to deliver out to that particular client, but they can still put a cheap sale. They can still put like a 90%, 80% of discount, all of a sudden, like branded items straight from the factory to the public. Have you seen that? This is what happened when QC, sorry, sorry guys, can I get a second please? Sorry, okay, so this quality control, it's just taking the final decision to accept the product or to reject the product. Okay, that is their motive. They don't want to think of anything else. But when we say quality assurance, it means they try their level best to avoid the product, the end product, to be rejected at the end. So it means they will try their level best to ensure the quality will be fulfilled during the quality control later, so that the product can be successfully delivered out for the shipment and it will not having any defect to be rejected. So quality assurance, it can be anything. For example, maybe by having like a daily base of checking, daily base of reviewing, or daily base of to do inspection of how they manufactured the product. So it means they want to make sure the assurance of the quality is there, so that the end product will not cause a huge loss. Because when we said the product is failed to fulfill the requirement and the product cannot be shipped out to the client, it means they wasted a lot of resources, they wasted money. At the end, they cannot ship it out. So, quality assurance, they responsible or their aim is actually how we can make sure the product will not be rejected later. So we will try all our level best for the assurance part, so that the product can be successfully accepted. Can understand these two sides? What is quality assurance? What is quality control? So the same thing happened in the software side. So can I just test the software which is developed and then to be rejected? Can I do that? Can I simply do that? No, because for example, I always like to use your FIP. It will be easy for you to understand. Okay. After spend two different semester, is it two or three? Okay, you have spent this much of time to complete your FIP, and then at the end of the day, I just do software quality control. I do the testing on your software, on your application, and then I said this is not fulfilling the objective. This is not fulfilling the requirement, and I reject your project. Is it acceptable? Is it something acceptable in the software development project? Can I simply do that? And can I simply do a chip sale for your FIP? As how manufactured product, they can just sell for a cheaper price, or they can sell it for the lower price than the suppose, and people can still go and buy. If I reject a software, I reject an application, can I still sell out that application or the software in a cheaper price, and do you think anyone will come and buy? Is it going to make sense if we do that to a software development area as how we do in the in the manufactured area? Do you think it can work? It will never. Okay, so when we said software quality assurance and software quality control, now we try to implement the quality assurance and the quality control which I have mentioned just now into software development project. Okay, so they have still the same concept. Okay, but it is more into the software area. Okay, so Quality assurance and quality control, they are totally opposite from each other. Okay, so as what I've mentioned, quality control, it is more about how they can evaluate the quality of the end product, and then how they can withhold or they can reject the unqualified, disqualified items. Okay, so the same thing goes when it comes to software quality control. But what is the difference here is the developed software will be tested, okay, for us to ensure the software is fulfilling the requirement mentioned by the client, okay, where the system is doing what it's supposed should do, and it's performing as how it is supposed should be. Okay, so when we said software quality control, it means we will do the testing on the completed software or the developed software to see if the developed software is fulfilling the requirement before we can deliver out to the client or not. So, as manufactured product, software cannot be simply rejected. We can say that, okay, we are withholding the software, we are rejecting the software, but we cannot just throw the software like that. We cannot simply put a chip sale for the software. So, what is our aim here? Software quality control, where we do the testing on the developed software to identify if there is any defect, if there is any part where the software did not fulfill the requirement, did not fulfill the quality, and then we want to fix it before we can deliver out to the client. Okay, so that is quality control, software quality control, where it's try to evaluate the quality on the developed software or on the developed product. Okay, contrast of that, okay, where software quality assurance, which is totally opposite than that. Okay, so software, just now we said quality assurance, it means they try to ensure the quality will be fulfilled by the end product so that it will not be rejected. So the same thing goes here when we said software quality assurance, it means how we can actually minimize the failure rate of the developed software at the end. Okay, how we can ensure that the activities which we use throughout the software development life cycle can actually prevent any errors or any causes of errors, any defects, and for us to detect that and to fix them in the early stage so that the end product will not be rejected later. So the aim of the quality assurance here is we want to minimize we want to increase the guarantee, we want to increase the assurance, and we want to minimize the failure rate, the defect rate, and also the cost which will be used on the defect part. So we want to make sure that we can reduce the failure rate or the uh, rejection rate of the product. So, for example, like how we said during the static testing, it means we do the early review, we do the early inspection. So, we have to make sure that we use this tool. We need to check this so that when we do the final testing later, we will not have much defect. There will be no much failure rate. So, there will be no rejection happen. So, in the conclusion, quality assurance is more to static testing, and quality control, software quality control, it's more to dynamic testing. Okay, in another example is software quality assurance is more to the verification, while software quality control is more to the validation. So during the quality assurance, we try our level best to do everything to prevent the failure, to prevent the defect, or to reduce all this risk. But when it comes to control, software quality control, we want to test the final product to see did we able to achieve what we tried during the quality assurance or not. So if it's happened, then it's good. Sometimes no matter how we try to implement the quality assurance during the quality control, there is still defect. But since it's a software, we cannot simply reject it. We still try to do the fixing of the defects or the qualification of the requirement on the quality side. So this will be the comparison between the software quality assurance and the software quality control. Can understand? Please do take note. You must understand this comparison. Okay. The difference between software quality assurance and software quality control. Okay. In the manufacturing side, we can simply reject a product. Okay, because we can still do something with that product. But when it comes to software project, we cannot simply do the rejection. So the difference here is during the software quality control, we conduct the testing to identify where is the defect part, where is the part which the system did not qualify or did not fulfill the requirement for us to do the fixing. Okay, and the quality assurance and the software quality assurance, they are actually having the same aim, where they want to ensure the quality or the end product later fulfill the requirement, fulfill the quality, so that it will not be having any issue and it will not be rejected later. Got it? Can understand? Okay, so back to the first slide just now. So this is just like a definition. Okay, so software quality assurance is a plan and systematic pattern, okay, of all the actions or any activity which we can do to make sure the product will be fulfilling the requirement. Okay, so a plan and a systematic pattern of all action necessary to provide educate confidence. So it means to guarantee that the product or the software will be conform to the requirement. So it can be any requirement, any technical requirement, quality requirement, and so on. Okay. So other definition is a set of activities designed to evaluate the process. So remember I said about the static testing or the verification, where we verify the process, what we do is correct or not. So quality control, software quality control, it's more on evaluating the product, the end product, while the software quality assurance is evaluating the process, if the process which we use to do throughout the software development life cycle is correct. Because if the process is correctly done, the process is following certain standard, So this can guarantee that the product later will be high quality. Okay, so this is a comparison. Software quality assurance evaluate the process, while quality control will be evaluating the developed or the manufactured product or the software. Okay, so all this is actually like a definition of the quality assurance from different sources. Okay, like IEEE, ISO, SEI, all these are. So I'm not really going through that. Okay, so this part, what I have discussed just now, the comparison between software quality assurance and the quality controller. Okay, so each of it, they serve different objectives. So I already discussed what is the objective of each of them, and quality control is actually part of the quality assurance. Okay, so here quality control is part of quality assurance mean during the software quality assurance, we ensure, okay, the process all need to be done. Everyone need to follow this. Everyone need to refer to this document. They must follow this standard. So that is quality assurance. Okay. But what we try to do during the quality assurance, we cannot guarantee it can fulfill the requirement. The end product can achieve the quality. So what we need to do, we need to support the quality assurance with the quality control. It means we need to do the software quality control to prove that what we have done during the software quality assurance has been achieved or not. So quality control here means we do the testing to confirm that the end product is actually achieved. The product is fulfilling the requirement. The product has all this quality. So the product cannot be rejected. So we need to prove that. Okay. So the same thing goes like what we discussed before. Just because we conduct the static testing doesn't mean we will skip the dynamic testing. Am I right? Because when we said static testing, it means we do checking all the documentation, we do the review, we do the desk checking, the inspection, and so on. But that doesn't mean that the final product will be guaranteed 100% defect free. So what we do, we still need to conduct the dynamic testing to prove that the system is actually having the high quality, the system is having fulfill the quality requirement, and we want to identify if there is any defect so that we can fix it. So the same thing goes here. When we said quality control is part of the quality assurance, it means we will do the quality assurance, okay, throughout the software development life cycle. But at the end, we still need to do the quality control to confirm if the end product is achieved or not. So that's why quality control is part of the quality assurance. Okay, got it? Can understand the comparison part of the software quality assurance and the quality control. Can Okay, so the next part is the software quality factor. So this one I'm not going very deep because these quality factors is something you have been learning for few semester in few courses now again and again. So I will discuss straight in our tutorial later. Okay, so the important thing here is when we talk about the software quality factor, okay, we are referring to this factor model, which is the Merkle factor model. So this Merkle factor model, it's classify all the software requirement into 11 software quality factor. Okay, and this 11 quality factor is under three different category, which is the product operation, product revision, and then product transition. Okay, so this is how the model look alike. Okay, so the Merkle classic factor model, okay, from the thousands of software requirements, we have this software quality requirements, right? So they group it into 11 quality factor. So if you see the number 1 until the number 11, so the total of 11 quality factor. Okay, so this 11 quality factor has been categorized into three different grouping or three different category of factor. The first one is operation, the second one is revision, the third one is transition. Okay, so under the product operation factor, we have five factors, which is the correctness, reliability, efficiency, integrity, and usability. So I'm not going to discuss one by one what is this, because it's something what you already know. Okay, and then product revision is having three, which is maintainability, flexibility, and testability. Okay, then under product transition we have three, which is portability, reusability, and interoperability. Okay, let's see how they actually group them into these three different groups. Okay, so when we said product operation factor, you can go to other slides, because I already described them one by one for each of the factors. Okay, so when we said product operation, okay, it means deal with the requirement that directly affect the daily operation of the software. So it means the software has been developed and now the software is going to be used by the client. It means for their daily operation. Okay, so when we said this product operation factor, this factor is referring to the requirement that can directly affect the daily operation of the software. So that's why we have this five, which is the correctness. So when we say correctness, it means how is the correctness of the output which we get from the daily operation of the software. Reliability, how well is the software reliable enough to be used, and then how is the efficiency of the software on the daily operation, how is the integrity of the software, and also how is the usability. So these five factors can actually affect the daily operation of the software. So that's why these five factors under the product operation factors. Okay, then when we said this all is the explanation of one by one, you can go through it, like the correctness. This is sample of requirement referring to the correctness. This is reliability, efficiency, and then integrity, and then usability. Okay, the next one, the next group is the product revision. So when we say product revision, it means it's deal with the requirement that affect the software maintenance activity. Okay, so product revision here means referring to the software maintenance activities. So in your software engineering before 2163, you have already discussed these three types of the maintenance, which is corrective maintenance, adaptive maintenance, and perfective maintenance. So, corrective maintenance, which is more on doing the maintenance on any defects, any fault, any failures happen during the operation. Uh, I mean, when the client is using. And then adaptive maintenance, it means when the client is requesting the current software to be running on different, how to say, environment or something without any changing of the software. And then when we said perfective maintenance, it means when the client want to improve the current software with something additional. It means they want to change, I mean, they want to add a new features using new technology, all these things, where there will be changes happen on the software. So when we set this maintenance activity, so this can be actually under the revision factor, where we have the maintainability, okay, and then we have the flexibility, and then we have the testability, okay. So these three factors, which is the maintainability, the flexibility, the testability, will be the one affecting the software maintenance activities. So some of it suitable for some of the maintenance activities, some might be suitable for more than one activities. Okay. Then we have the third group, which is the product transition factor. So product transition factor means it deal with the requirement of the adaptation of the software to another new environment or to work with another new software. So it means like working with another software system. Okay, so under this product transition, we have the balance three factors, which is portability, reusability, and then we have the interoperability. Okay, so you should know all this. So portability is more on to working on different environment, different operating system, different hardware. Okay, then reusability is more on reusing the software functions or the module on another software. And then interoperability, where the software can be communicating or interfacing with another software. Okay, so this will be the total of the 11 factors as mentioned by the Meckel factor model or Meckel classic factor model, which they group them under three different factors group. Okay, so the first five: correctness, reliability, efficiency, integrity, usability under the operation factor, and then maintainability, flexibility, testability under the revision, and then portability, reusability, and interoperability under the transition. Okay, got it? Okay, so this one is nothing because this is talking about the alternative model. Okay, are you guys okay? So far, so good. I know that this last three chapters is like kind of very, very boring. I have no choice. So, what I was actually thinking is, can we just focus what will be coming out for final exam? Because it will be like very, very theory. Believe me, it will be very theory. I don't even like these three chapters, last three chapters, because it will be very theoretical things, and it's not something about like testing things. It will be very theory. quality assurance is very boring things because it's like too many things, but I don't know why we need it. Something like that. Okay, I think can we stop here first? My sore throat is getting worse. I'm controlling myself from coughing. Okay, so what I can do is I need to check back what are the important things from these three chapters for the final exam. Then we can discuss based on that because when we discuss your tutorial question, believe me, please do study back tutorial question. Don't ever miss that. Okay. So when we discuss like chapter 11, chapter 12, all this is actually I will refer back to our tutorial question. So based on the tutorial question, I will refer back to the slide to show you uh, what is it about. Okay, and also chapter 11, there is too many formula which will be kill you. Okay, so I will only focus the matrix which will come out on final exam, because if no means you will not able to cover everything. Do you get what I'm saying? Because these three topics, it's a very very theoretical, and it's carry 50 marks, and the possibilities for you to fail is actually coming from these 50 marks, believe me, because I always face that. Okay, so don't worry. Okay, I will check back what are the things which we need to concentrate from these three chapters, and then we will directly do the discussion based on that. Please make sure attend the lecture, attend the tutorial, please, so that you will not miss out what we are discussing. Okay, can understand? So I will do that part tonight to do the checking. So tomorrow when we meet up for the lecture, then we can focus on that. Okay, got it? Can understand? Okay, because the first 9 chapters is much more better than this last 3 chapter. That's it. It's like a very theoretical, and it will not be something easy to go into mind. So I know. Okay, so can we end the session here? So we will continue tomorrow morning, 10 o'clock online. Okay. So let me do my checking, and then tomorrow I will focus on what are the areas which we need to discuss, which is the important one, because all the many theory things is actually you might not even need it at all. It's just for theoretical things. Okay, so I will do the discussion and I will do the checking, then we will discuss the tutorial questions and the lecture together, so that it will be easy for you to understand where how to answer the questions. Okay, Kenna. Okay, so if there is no question, then we can end the session here. So thank you very much, guys. I will see you tomorrow morning.